Right now, something critical is happening. Out in the Gulf, ships are slowing down, some are turning around, others are waiting, because one narrow stretch of water is becoming unpredictable, and the entire world is watching. Because through that single passage flows something we all depend on, 20 million barrels of oil every day. And that's not just a massive amount of oil, that's the energy that keeps our modern life running. And it all squeezes through a gap just 21 miles wide, the Strait of Hormuz. If that flow breaks, it doesn't stay out there, it reaches you and me directly. When you see the prices rising at the gas station, or in the supermarket, or in your electricity bill. So the question is urgent. What are our options if this route fails? And since we are aware of this situation for years, why don't we have another route? Look at a map. Almost everything exported from the Gulf funnels into this one point. Saudi Arabia, Iraq, Kuwait, the United Arab Emirates. For them, this isn't just a route, it's the only way out. And on the other side of that passage are the world's biggest economies, dependent on a continuous flow of oil. Whole industries are running with this oil. And when that chain breaks, it doesn't slow down, it ripples. Energy becomes more expensive, factories adjust, fertilizer costs rise, and then, quietly, food prices follow. That's how a disruption in one narrow channel spreads across the entire planet. But if this route is so critical, why not just secure it? Why not send in navies, protect the ships, and keep everything moving? Well, that's exactly what has been tried. Warships patrol the region. Naval fleets track every movement in the strait. Tanker convoys move under military escort. And still, ships get attacked. Threats come from everywhere, like hidden mines in the water, missiles coming from the coastline, or drones that are hard to detect and even harder to stop. The problem is, you're not protecting a single location. You're trying to secure an entire corridor, hundreds of kilometers wide with constant traffic. And the threats don't need to shut everything down. They just need to create uncertainty, because the moment insurers pull back or companies hesitate, ships stop moving. And that's exactly what we're seeing right now. Not a total blockage, but something more subtle. Delays, higher risks, rising costs, which means you can protect the route, but you can't make it truly safe. So if you can't guarantee safe passage through Hormuz,
what other options do we actually have?
What if we try to move the oil not on water, but on land? This idea falls apart as fast as you try to picture it. One supertanker carries 2 million barrels. To replace that, you'd need 10,000 trucks. Now imagine that. Endless lines of trucks, crossing deserts, crossing borders, day after day after day, just to replace one ship. Now multiply that by dozens, every single day. At some point, it becomes clear you're not solving the problem. You're trying to rebuild the entire global oil system on wheels, and that system collapses under its own weight because the trucks would burn massive amounts of oil on their way. So maybe the solution is trying something more permanent, like pipelines. Right now, some oil is already bypassing Hormuz, and new routes are being planned, expanded, and debated across the region. So what if we bring all of them together? Saudi Arabia built a massive pipeline back in the 1980s, later expanded over time. It starts near Abqaiq, one of the world's largest oil processing hubs, and runs over 1,200 kilometers across the desert to the Red Sea port of Yanbu. That line can move around the 7 million barrels per day. The United Arab Emirates followed a similar strategy. In 2012, they completed a pipeline from Habshan to the port of Fujairah on the Gulf of Oman, bypassing the Strait of Hormuz. That adds roughly 1.5 to 1.8 million barrels per day. And then there are northern routes, pipelines from Kirkuk in northern Iraq to the Turkish port of Ceyhan on the Mediterranean Sea. On paper, this system can move around 1.5 million barrels per day, but in reality, it rarely does, because this route runs through regions with ongoing political tensions. Now let us look at what's being planned. The United Arab Emirates are working on expanding capacity in Fujairah, adding new connections from offshore fields directly to export terminals outside the strait. That could add another one to 1.5 million barrels per day. So if you add everything together, existing pipelines, expansions, and new proposals, you might reach about 11.8 million barrels per day.
Which means, even in the best case scenario, you're still missing millions of barrels every single day.
Because the Strait of Hormuz handles around 20 million. And that's before reality kicks in. Different countries, different interests, infrastructure that isn't fully built. routes that depend on political stability. They need pressure, stations, security. One disruption, and the flow slows down or stops, so even your best alternative is still not enough. So if you can't move it by land, and you can't move enough through pipelines, then maybe the answer isn't going around the problem. Maybe it's something else entirely. What if you didn't avoid Hormuz, but replaced it? A completely new route cut directly through land, from the Gulf to the open ocean, a path for the largest ships on Earth. And this isn't science fiction. It's been proposed for decades. A canal across the United Arab Emirates, or one across Saudi Arabia. Projects worth up to $200 billion. Every time tensions rise, the idea comes back, because on paper, it feels like the perfect solution. And if this actually worked, it would be one of the most ambitious engineering efforts ever attempted. It wouldn't just change shipping routes, it would change how the global energy system works, a single project capable of reshaping one of the most critical flows on Earth. Right now, there are several versions of the Hormuz bypass plan. One idea would push a route across the United Arab Emirates, linking the Gulf to the open sea near Fujairah. Another, even more extreme version, would stretch across Saudi Arabia, cutting a new maritime corridor hundreds of kilometers through the desert toward the Arabian Sea. The goal is clear: to create a full alternative to Hormuz, a safe route for fully loaded supertankers to reach their destination without interruption. But there's one problem. These routes don't pass through empty, flat land. They cut across desert plateaus, solid rock, and entire mountain ranges. In some sections, the terrain rises hundreds of meters above sea level, which means this isn't just about digging a canal. It means reshaping the land itself, carving through elevated terrain, moving massive volumes of rock, building a route where none was ever meant to exist. To make that work, engineers would have two theoretical options. Idea 1, go straight through the terrain. That means blowing your way through rock, tearing apart mountains, and moving insane amounts of material out of the way. Idea 2, accept the terrain and build around it with massive lock systems. That means ships would not simply sail through. They would be raised, chamber by chamber, step by step, lifted uphill across the route's highest sections, then lowered again on the other side. And just remember, these are 300,000-ton supertankers, some of the largest moving structures on Earth. Every gate, every pump, every wall would have to work perfectly, because at this scale, there is no room for error. If a single lock fails, if a gate doesn't seal properly, or pressure builds up where it shouldn't, you're not dealing with a minor issue. You're dealing with millions of tons of water moving out of control, a tanker trapped inside, water levels collapsing or surging through the system. And in the worst case, you're looking at structural failure, flooding, and a complete shutdown of the entire route. But let's say engineers actually solve this challenge. The canal is there. It cuts through deserts, through mountains. There's still one thing we haven't talked about yet, because no matter how advanced this system is, no matter how perfectly it works, it still comes down to one thing: a single route carrying everything. One incident, one decision, and suddenly the flow stops. At first, it looks almost harmless, just a few delayed tankers waiting in the Gulf. But then you feel the impact in your daily life. At the gas station, when prices jump overnight. At the supermarket, when food becomes more expensive. In your electricity bill, slowly creeping higher. Because this isn't just oil, it's fuel for transportation, energy for entire cities, the base of countless products, plastics, chemicals, fertilizers. It moves trucks, it powers factories, it supports the systems that put food on our shelves. And even with a $200 billion bypass canal, once again, it would all depend on one narrow path, controlled by a handful of actors, which means, in the end, we'd still be dependent, not on the canal, but on whoever has the power to stop it.